Howdy, this lesson is going to walk you through rotations. This is our third and last rigid transformation that we're going to be talking about. So a rotation is a turn. So if I have this letter T here, rotating it would mean I'm just turning it, okay? And we're going to be learning about turning it a certain amount of degrees, okay? But I could also turn it the other way. So there's also a direction going to be involved with rotations. So before you can rotate an object, you need to know which direction you're going, and you need to know how many degrees that you're going to rotate it. Okay, you notice when I was rotating, when I was turning this letter T, it didn't change size and it didn't change shape. That means it's a rigid transformation. Okay, so let's look at a coordinate plane. So we know that a coordinate plane is made up of 4 quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Quadrant means 4. Quad means 4. So each quadrant is made up of a right angle, which is 90 degrees. Okay, so 90 degrees, another 90, another 90, and another 90. Okay, and then the next thing that you need to know is clockwise and counterclockwise. So I have my watch here, and you can see the second hand is moving, so it's going around the watch. That would be considered clockwise. Okay, so up and around to the right. Okay, so counterclockwise would be the other way. It would be going opposite of a watch or clock hand. Okay, so if you have trouble with directions, if you can think of a clock when you think of clockwise or counterclockwise, that should really help you out. Okay, so I'm going to take an M&M, and I'm not going to worry about which way the actual M&M is rotating, which is why I'm using a circle. Okay, but let's talk about rotations. Okay, so I have this M&M starting in quadrant 1. If I asked you to rotate it 90 degrees clockwise, so think about clockwise, it's going to be going this way, okay? And 90 degrees means it's going to move 1 quadrant away, because remember, we don't count the quadrant that we start in. So 90 degrees would be 1 away, okay? 180 would be 1, 2 away. 270 would be 1, 2, 3 away. And 360 would be 1, 2, 3, 4. It would end up where it started. Okay? So if I asked you to move this M&M 180 degrees clockwise, so clockwise is going this way, moving once would be 90. Moving again would be another 90, and 90 and 90 make 180. So it would end up in quadrant 3. Okay. Quadrant 3, let me put it back in quadrant 1. If I had asked you to rotate it 180 degrees counterclockwise, so it's going opposite now, that would be 90, and that would be 180. So 180, it actually really doesn't matter, just so you know, it doesn't matter what the direction is with 180, because it's always 2 spots away. So it's going to go 2 away, which is always going to be 2 away depending on, no matter what the direction is. Okay, so now I'm in quadrant 3, and I want you to rotate it 270 degrees clockwise. Okay, so I wrote out my degrees here. So clockwise is going this way. So 270 would be 1, that would be 90. 2, that would be 180. 3, that would be 270. So your M&M would end up in quadrant 4. Okay, if I asked you to rotate it 270 degrees counterclockwise, so counter is going this way, 90, 180, 270. Okay. What about if I started in quadrant 2 and I asked you to do 90 degrees actually, let's put these on top of each other. 90 degrees clockwise with the blue. So clockwise, 90 degrees. Okay. 90 degrees, or excuse me, 270 degrees counterclockwise with the yellow. 90, 180, 270. So 90 and 270, if they're going opposite directions, they're going to end up in the same spot. So if one is counterclockwise and one is clockwise, they end up in the same spot. Okay. For this blue M&M, if I asked you to rotate it 360 degrees clockwise, it would go 90, 180, 270, 360. Okay, so hopefully you're getting the hang of that. The biggest thing for this particular assignment, trying to do this remotely, is you need to be able to identify what quadrant a rotation is going to end up in. So if you need more help with this, make sure you let me know. Okay, but how do we actually do that with objects? Okay, so I have this line segment here, line segment AB, and I want you to rotate it 270 degrees counterclockwise. So 270 counterclockwise. You don't have notes for this anywhere, so you could just watch for this. So at my home, if we were in class, I would have given you something called patty paper. It's basically like tracing paper. You can see through it. I happen to have this as a piece of parchment paper that you use for baking at home. Okay. So what I'm going to do is I am going to trace the line segment that I need to rotate. Okay. But every single rotation happens around a certain point. And for 8th grade math, that point is the origin. So what I need to do is mark off a little bit of my origin. Origin is where the graph is 0, 0. So right here. Okay, I'm going to put my pen, my pencil, whatever I have there. And I'm going to rotate this 270 degrees counterclockwise. So I lift up my paper and I'm going to turn it until they line up again. Okay, so you can see right here where my pen is, it's not lined up with the graph there. So when my pin marks there in the center at the origin are lined up with the graph, that was 90 degrees rotation. So I need to do 270. So I need to do it again. It's not lined up. It's not lined up. There we go. And then that was 180. So one more time would be 270 degrees. So now I could come in here and mark where it would go. Okay, so you might be looking at it and think, that looks kind of funny. Well, remember, this isn't a reflection. It's not a flip, it's a rotation. So it is gonna look a little different. It's the same length, the length didn't change, but it might not look exactly how you thought it would look. Okay, so I use this patty paper at home. I'll give you some tips on how you could do it if you don't have something like this, or parchment paper, excuse me. So now I have this triangle, X, Y, Z, and I want you to rotate it 180 degrees clockwise. Okay. So I can trace my triangle, and I'm labeling each point even on my paper so I make sure that the labels get in the right spot. Every rotation happens around a fixed point. In 8th grade math, that fixed point is the origin. So I'm going to trace a little bit of the origin so I can know when I've done 90 degrees. So this is 180 degrees clockwise. So I'm going to put my pin on the origin. And you can see as soon as I start rotating clockwise, the pin marks are not lined up with the coordinate plane. my axes. As soon as they line up again, right there, that was a 90-degree rotation. But I need 180, so I have to do it again. Okay, so when I have it lined up again, that was 180. And I can lift up my paper and label it. Okay, so I know some of you are probably thinking, how am I supposed to do that if I don't have anything like this special paper at home? Well, I'm going to help you out, okay? And then the last one I want to do is square T. Okay, I'm rotating around the origin. And let's do 90 degrees counterclockwise. Okay, so counterclockwise is going this way. And I need to pick up my paper and rotate, turn it till they line up again, which would be right here. If you're looking at it and saying, Ms. Pena, that doesn't look right, well, remember, this is not a reflection. It's not reflecting over the x-axis. It was a rotation, okay? But if I just gave you this right here, and I said, what happened between T and T prime? Some of you might have said, it looks like it was reflected and then translated. So it looks like it was flipped over and then slid up. Some of you might have just said it was translated down and to the left, okay? But another choice is that it was actually rotated. So if I just gave you this, there's a couple of options that it could have been. One of them was a rotation, but there are other things that could have happened, okay? So that you might come across that in math where you see multiple transformations that could have happened, okay? So I want to show you a couple things on your assignment. I'm not going to make a different video this time. So when I have your assignment, well, first let me go, sorry. When you are at home and you're trying to figure out how are you supposed to do a rotation if you don't have this thin paper. So one thing you could do is you could turn your brightness all the way up on your Chromebook and then use a soft tip like a marker, not like a pencil that's going to scratch your Chromebook screen, and you could turn your brightness up on your Chromebook screen and then use a piece of paper up against your Chromebook screen that would then be a little see-through if your brightness is up. You could, if you have a printer, you could print out the paper and then hold another just regular piece of copy paper on top of it up against a window. If you have tracing paper, patty paper, parchment paper, you could do that. But I am going to go ahead and assume that not everybody has those resources at home. And so your assignment kind of reflects that. So a lot of your assignment basically says, like number one, it says how many degrees clockwise was this rotated to get from Q to Q prime. So it tells you the direction, so you have to go clockwise. How many degrees did I rotate it? Okay, and then a lot of your problems are like this. If I rotated a figure a certain amount, so in this case 90 degrees counterclockwise, I want to know what quadrant it ends up in, okay? So a lot of them are like that. So you're not actually going to rotate it because I don't want to make you rotate something that you might not have the resources at home. So just tell me where it ends up. And then on number 5, you might actually have to use your computer for part of it, or you can print it out. But you're going to reflect this shape first over the y-axis, okay? Then you're going to translate it. You're going to slide it up, and then you're going to rotate it 90 degrees. And I want you to tell me where it's going to end up? What quadrant is it in? Some of you might be able to do that in your head. Some of you might need to actually reflect it and translate it to be able to answer that question, okay? So hopefully those little tips help. But basically, I'm trying to make sure that if you don't have some kind of paper or you're not really sure how to actually do the rotation, you're just identifying it, okay?